Okay, getting into solving by factoring. We'll talk about quadratics here in a little bit, but I want to talk about when you factor, you should always look for what's called the greatest common factor, or the GCF. So it's basically what are both of the terms, or all three of the terms, or all four of the terms each divisible by. So here I notice they're both divisible by 6. 12x divided by 6 is 2x. 6 divided by 6 is 1. Make sure you put your greatest common factor out in front. And there it is, factored with the greatest common factor. If you want to check it out, just kind of mentally distribute the 6, and you should get back to 12x plus 6. The second one I've got here, number 49 and 9 are both divisible by 9. But x squared and x are also both a common factor. So I'll divide out that x and get, or x squared divided by x and get x. Divide that out and get 1. And again, my greatest common factor on the outside. Okay, 51x minus 3. They're both divisible by 3. I know 51 doesn't seem like it, but if you add 5 plus 1, the digits of 51, and I get 6, since that number is divisible by 3, so is the number 51. So I get 17x minus 1 over 3. Now, you don't always get plus 1 or minus 1. That just happens to be coincidence. But always look for the greatest common factor. All right, when it comes to factoring and what it means to factor, even if I was just talking about numbers, the factors of the number 25 would be 1 and 25, 5 and 5. They're the two numbers that multiply together to give me that 25. Factors of a trinomial is a couple of binomials that multiply back, or they FOIL back into this original problem. So I look at the factors of the first term, and to get x squared, it's always going to be x times x. Okay, so that's what all of these have in common. They're all x squared. I'm going to look at the factors of negative 48 that add up to be negative 2. So negative 1 and positive 48, 2 and 24. Oh, actually, one of them's got to be negative. Let's see what negative 3 and 16, negative 4 and 12, or negative 6 and 8. Now, none of these give me negative 2, but this one gives me positive 2. If you're ever off by a sign, just make this the positive one, and make that at the negative one. So if I go plus 6 minus 8, that adds up to be negative 2. So if I'm going to check, I'm going to take x times x, x squared, x times negative 8x, 6 times x, so positive 6, and then multiply the last ones, get negative 48. So what I just did is first, outside, inside, last. Those two combine to give me a negative 2x, which is my original problem, so that is the correct factoring of that polynomial. Okay, again, x and x, factors of 9, 1 and 9, 3 and 3. Which one of these add up to be 6? 3 and 3, and I'll go negative 3, negative 3. Okay. What I can do is, I'll check this out, or what I can do is write this as just x minus 3 to the second power, because it's the same thing twice, but I'll just check x times x, x squared, minus 3x, minus 3x, plus 9. Those two would give me a minus 6x, so there's the correct factoring. Okay, x and x again. Factors of 16. Okay, 1 and 16, 2 and 8, 4 and 4. Those are the ones that add up to be 8, so plus 4 and plus 4. So x plus 4 squared. Okay, x and x. 2 and 1. Okay, but it's negative 2, so I could go negative 2, positive 1. That's going to add up to not be 6. I could go positive 1, negative 2. I didn't mean to put that in order pair. Okay, that's not going to add up to be 6 either, so it happens to be not factorable. Okay, all of these, again, what they had in common is they were just x squared, so I could just go, first one's x, the next one is x. Okay. When it comes to ones that are an a that's a different number, and what I mean by a is, if you remember from the quadratic formula, in front of x squared is the variable a. It's actually a number, so a would be 4. Your b is the number in front of x, which would be the -4, and then c is going to be your tail number, -3. I have y's here, x's. It doesn't really matter the variable. I'm going to show you what's called the AC method. So it is to take the value of a and multiply it by the value of c. So there's AC, a times c. That's why it's called the AC method. And you get -12. Okay, I'm going to write the factors of -12 that are going to add up to be my middle. And since it's -12, one's positive, one's a negative, it looks like these are my winners. And I'm going to rewrite the b as those two numbers with a y in them. Now, a is going to stay the same, and c is going to stay the same. And I'm going to do what's called factored by grouping. Factored by grouping is kind of like finding the greatest common factor, but instead of doing it for all 4 of the terms, 1, 2, 3, 4, I'm going to group 2 at a time. So 4y squared and 2y are both divisible by 2y, so I'll divide that out by 2y. And I'm left with 2y plus 1. Okay, now the thing is, when I factor by grouping, in my second set of parentheses, I need exactly 2y plus 1. So what can I divide these two by to get 2y plus 1? Well, I could go with 3, but that's going to give me a -2, so I'll have to make sure I divide out a -3. Okay, so now my greatest common factor of here is 2y plus 1. My greatest common factor of here is 2y plus 1. Take that out, and I get 2y minus 3. But if you recall, every time we take out a greatest common factor, I got to take that and put it out in front of my parentheses. So I'll put a 2y plus 1, and there is the factoring of my polynomial. Okay, I'll try that again here. A, B, C, so take A times C. So 10 times a -1 will give you -10. The factors of -10 that add up to be -3. Okay, let's do all of them, but I recognize that it's a +2 and a -5. So we'll rewrite that A is the same, the C is the same, but this 3 will get written as 2x and 5x. Take out my greatest common factor of 2x, and I've got 5x plus 1. So I need a 5x plus 1 out of here. So the number I'll take out is a negative number. So 5x plus 1, 2x minus 1. There's my factoring. Okay, do it again real quick, but this time I've got two positive numbers. I got an A and a C, so 3 times 5. If I'm going pretty fast, make sure that you just kind of sit down and you can pause, regroup, or rewatch or whatnot. Okay. I just want to get through it fairly quickly so I can make the videos a little bit shorter. Okay, so here are the first two. They have an x in common, that's it. Okay. I've got 3x minus 5. I come to here and, I need to get 3x minus 5, but that's 3x plus 5. I could try a positive 1, but that's going to give me this. So, since that's true, either I got to go back and just double check if I made a sign mistake. Okay, -5 and 3 will add up to be that. Or what could happen is, again, it's not factorable. And I noticed that because I've got 3x minus 5 there, 3x plus 5. Even if I were to switch that to a -1, that would become a -3 and a -5. They still wouldn't be the same. I can't factor that. A common pattern that you've run into in the past is called the difference of two squares. Okay, two squares are two perfect squares, so numbers like 1, 4, 9, 16, 25, etc. They're all numbers you can take the square root of and get a perfect whole number. So 11x 4. So I'll go 11x plus 4 and 11x minus 4. X plus 5, x minus 5. It's this number here would be the first term. This number right there is the second term, and it's always 1 plus 1 minus. Okay, I can even do it with two of them. So there's 2x squared is 4x squared. Okay, you can even do it with a fourth power. And notice that these are perfect squares as well, and it's still the difference that can get factored more.